In this video, we're going to look at solving an integral by applying U substitution and then partial fraction decomposition. So here we have integral x to the 1/3 plus 1 divided by x to the 1/3 minus 1 dx. Our strategy will be to apply U substitution first and then partial fraction decomposition. We're going to let U be equal to x to the 1/3. Cube both sides, we get U cubed is equal to x to the 1/3 cubed. That's going to give us x. Now differentiate both sides, and we get 3u squared du. That's the derivative of left-hand side, and derivative of right-hand side is just dx. So let's transform the integral. We have x to the 1/3 plus 1 divided by x to the 1/3 minus 1 dx. That's going to be integral of u plus 1, because x to the 1/3 is u, divided by u minus 1 times dx, and dx is all of this here. That's 3u squared du. Let's simplify the numerator and multiply 3u squared. Let's multiply it through, and we're going to get 3u cubed plus 3u squared divided by u minus 1 du. Now the degree of the numerator is clearly 3, because 3u cubed plus 3u squared, the leading term, is 3u cubed, and degree is 3. The denominator is u minus 1, the degree of the denominator is 1. Since 3 is bigger than 1, we have to apply long division first, and then apply partial fraction decomposition. So we have x to the 1/3 plus 1 divided by x to the 1/3 minus 1 dx, and we did a u substitution, and we have 3u cubed plus 3u squared divided by u minus 1, and we're now going to do long division. So we have 3u cubed plus 3u squared divided by u minus 1. How many times does u go into 3u cubed? Well, that's 3u squared. 3u squared, now distribute, and we get 3u cubed. 3u squared times minus 1 gives us minus 3u squared. Now put a minus and put a bracket here. It's very important to have this bracket and distribute the negative sign. 3u cubed minus 3u cubed is 0. 3u squared minus 3u squared gives us 6u squared. How many times does u go into 6u squared? That's 6u. 6u times. 6u times u is 6u squared. 6u times minus 1 is minus 6u. Distribute a minus sign. Let's put a filler here, plus 0u. 6u squared minus 6u squared is 0. 0u minus 6u will give us 6u. How many times does u go into 6u? 6 times. 6 times u is 6u. 6 times minus 1 is minus 6. And so now let's subtract. And let's put plus 0 here. And 6u minus 6u is 0. 0 minus 6 is just 6. This is the remainder. So we can rewrite the integrand, 3u cubed plus 3u squared divided by u minus 1. That's equal to the quotient, which is 3u squared plus 6u plus 6 plus the remainder, which is 6, divided by the denominator. All right, so what we have is integral 3u cubed plus 3u squared divided by u minus 1 du, and we did the long division, and we have produced the integrand. We've simplified the integrand as 3u squared plus 6u plus 6 divided by u minus 1. And now it's going to be very easy to integrate, and we'll have our answer. The first thing we'll do is integrate term by term, so let's split off the integrals. That's going to be integral 3u squared du plus integral 6u du plus integral 6 du plus integral 6 over u minus 1 du. Let's simplify a little bit more, remove the constants. So 3 is a constant, passes through the integral. We get 3 integral u squared du. 6 is a constant, passes through. We get 6 integral u du. And another 6 comes out, we get 6 integral 1 du plus 6 integral 1 over u minus 1 du. Now we can integrate term by term. Let's apply the reverse of the power rule. Integral of u squared is u cubed. Divide by 3. Integral of u is u squared. Divide by 2. Plus 6 times u. Integral of 1 is just u. Plus 6 times log of u minus 1. Plus c. Let's simplify a little bit more. 3 cancels with the 3. We get u cubed. 2 and 6 cancel. We get 3u squared. Plus 6u. Plus 6 log of u minus 1 plus c. Now let's put u back in. U is x to 1/3. So what we get is x to 1/3 all cubed plus 3 times x to 1/3 all squared plus 6 times x to 1/3 plus 6 log of x to 1/3 minus 1 plus c. Simplifying further, we get x to 1/3 cubed, that's just x, plus 3 times x to the 2/3 plus 6 x to 1/3 plus 6 log of x to 1/3 minus 1 in absolute value plus c. This is the answer. All right, thanks.